why does it get dark at night? You might think that this is a rather trivial question. Surely when the sun goes down, we have to make do with the feeble reflected light from the moon, and the even more feeble light from the distant planets and stars. But the answer is actually more subtle and interesting than that. It's known today as Olber's paradox, after Heinrich Wilhelm Olber'S, a 19th century German amateur astronomer. Imagine that you're standing in the middle of an infinitely large forest, and you shoot an arrow that keeps going until it hits a tree trunk. It will eventually hit one, however far away that tree may be. Now imagine an infinity of stars evenly distributed throughout an infinite universe. The light that reaches us from these stars is like the example of the arrow, but in reverse. For no matter where we look in the sky, we should always see a star in our line of sight. There wouldn't be any gaps where we don't see a star. And the whole sky should be as bright as the surface of the sun all the time. Incredibly, it's taken many centuries to solve this puzzle. And the answer turns out to be one of the most profound truths about our universe that we've ever discovered. Astronomers have long argued about whether the universe might indeed be infinite in extent, and therefore contain an infinite number of stars. If it does, then maybe the very distant stars are just too dim, which is why we see so much blackness in the space between the stars we do see. However, this simple explanation just doesn't work. If we imagine all the stars grouped into concentric shells around us, like layers of an onion, extending out to infinity, and assuming that all the stars on any given shell all shine with the same brightness and are all equally spaced throughout the universe, while the stars in the innermost shells will shine brighter because they're nearer, the stars in the shells further out will be dimmer. But since those shells are bigger in area, they'll hold more stars. It turns out that the overall brightness of each shell is the same. In other words, lots of more distant, faint stars contribute as much total light as fewer, nearer, and therefore brighter ones. So the dimness of distant stars doesn't resolve the paradox. Various solutions have been proposed over the centuries. Maybe the universe is finite in extent, and what we see is all there is. Or that dust and gas in interstellar space blocks the light from the more distant stars. But these don't resolve the paradox either. The expansion of space certainly complicates matters because it means the light from the edges of the visible universe is stretched to wavelengths longer than the visible range. But this still misses the crucial correct answer. The real reason the night sky is dark is because the universe had a beginning 13.8 billion years ago. So we can only see those stars, or rather galaxies, that are close enough to us for their light to have had time to reach us. Beyond these will be galaxies whose light has not yet reached us, nor will it ever do as the universe expands. Scientists are often asked what proof they have that the Big Bang actually happened. They usually quote quite technical answers that can leave people just as baffled. But it's much more fun to turn the argument around. Rather than saying that the reason it gets dark at night is because the universe had a beginning, we can say that the best proof of the Big Bang is because it gets dark at night.